Okay, so here we are. Mr. Zack from the Dadabots and I are here.
Hey.
Uh-oh. Oh, there you are. Okay. The internet just lagged out pretty hard, but hopefully we won't have too much lag today. Um, right. Okay, so let's get right into it. Welcome, Zack. Would you like to say a couple words or mention any links or things you'd like to promote or anything?
Yo, Wolg, thanks for having me on the show. Yeah, Zach from Dadabots. We're dadabots.com. We're mostly a YouTube channel, do infinite live streams using generative raw audio AI, imitating bands to infinity. I think that's about all. Excited to hang out.
Sick. All right. Okay, so oh crap, my voice is clipping. Okay, so why don't we start with I wanted to ask you about like what are you working on these days?
Yeah, lately I've been really into real-time neural nets that are quite faster than some of the old live streams that CJ and I used to run using sample RNN. So we're looking into these VAEs, especially like RAVE. The R in RAVE stands for real-time audio variational encoder. So I'm very interested in that. Really interested in taking what's going on in the research community in some of the big tech companies, giving it to the experimental musicians, partnering with them, making cool things with actual artists, and seeing what kind of craziness ensues from that.
Sweet. And you guys are working, you and CJ are working also with Ben Incanti and Rob Clouth, right?
Totally, yeah. We got a project called Data Mind Audio, working on putting this Rave encoder into a VST plugin, the
Hmm.
place where producers are naturally working in the DAW. And we're trying to connect to as many artists like you, trying to get cool sounds from all the world's best sound designers. We're working with Rob Clouth, Vadix as well, and looking to get artists to give us their sample libraries, and we build models that other people can use as rather than sampling or sample packs like Splice or something, kind of generating this like hybrid of sampling and synthetic media for people to build their own stuff off of.
Awesome. That's really cool. Um, yeah, I wanted to ask you a little bit about like what does training look like for those, like for the rave models? I remember a little while ago you trained one on my stuff. Like, how long does it take to train one of these
Hmm.
rave models?
Yeah, Rave's faster than some of the like larger models that are out there,
Mhm.
but it focuses on one genre or like one artist discography or like sound world. It's not quite able to stretch the limits of like multi-genre yet. So it trains pretty quick if you have a GPU. So I have like a gaming computer with a GPU on it, and it'll take a few days on there. Um,
Is that running
and it
like your only task on that computer for the whole several days is just that?
I can squeeze some more out of it. I can still browse the web and stuff, but yeah, it's like it's one it takes up like a lot of my compute for it, right? Like I'm using like
Right.
80% of my GPU utility.
Fuck. Um, yeah, I kind of wanted to ask you about that also. Like, so do you like, are you like, what's, I guess this is kind of a not that interesting question, but like, I guess, so Rave 2 just came out, or like the second version or whatever just came out earlier this year,
Right.
right? And, um, yeah, like, are you like, do you know the guys that made this? Or are you like in contact with because they're it's like some people from Earcam, right?
Totally, yeah. It's this awesome dude, Antoine, and he's at EarCam, finished his PhD study there, I believe. And part of that was making this max object called in tilde.
Hmm.
So that's so cool because you could put any neural net from PyTorch into it. Um,
Wait.
and I think
Whoa. Does it load like any arbitrary like state dictionary or like model configure whatever from PyTorch?
it's
I thought it was like
capable of
just
it.
okay,
So yeah, but you got to configure everything the right way and build. In Python, you have to build the right methods when you save it all out.
right.
Um, but it can be extended, so it's not just exclusive to Rave. Although Rave was made the main thing that they were trying to put into it.
That's very
Um,
exciting for on my side.
it's pretty sick. Yeah, they have
Yeah.
jitter now too, so I guess you could use like jitter for like visual neural nets in
Oh,
in tilde now.
that's very cool.
And yeah, he's focused on Rave. CJ kind of partnered up with him back about a year ago and would meet with him periodically, just getting advice about
Say.
what's going on with Rave and all that.
Mhm.
So now he's working with Harmony, and they're going to be creating an open source version of Rave called Oobleck,
Oh,
which is pretty cool.
that's a great
Um,
name.
yeah, right. Yeah, right now Rave is not under a commercial license or anything,
Mhm,
which is great if you're just researching or if you're an artist, still totally available for you to do whatever you want with.
mhm,
Um, if other like VST companies want to use it, your cam has to kind of give you permission for that.
mhm.
So they're trying to give one that's just like open for any hacker to work on and build whatever they want with it.
That's cool.
Also kind of yeah, testing what the limits of like I mentioned it was for one genre,
Right.
but like how many could we get if we designed it specifically as a general auto encoder that could
Mm,
generate uh, latent space for many types of music that
mm.
isn't just fit into one style.
Do you find
So
so my like little experiments with the model you guys trained on my music, it felt like
mm,
there was like part of the distribution of the music that it modeled really, really well, but it was quite hard to get it to do anything but that one thing that it had learned. Is
yep,
that kind of characteristic of the the way that it works or whatever?
it can be like that if you don't put some care into how you create your data.
Mm,
So I've been learning a lot of new techniques with augmentation of the data.
Yeah.
One problem, I mean, it really loves to do drums, and like that might is that the kind of mode
That's what
of
it ended up
stuff that you
with.
noticed? Yeah, 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 okay. So
They
I
were
found
very
it.
like they were so similar to what I would do. It was like from a certain era of my music. It had like
Uh,
like zoned in on one particular kind of era of my music, but it made it so perfectly that I was like, all right, well, I can quit now.
yeah, so it almost like over memorized this one
Mm,
specific thing, right? And it kind of
yeah,
like collapsed onto that. So trying to find ways that either making more variations of the stems or the way that you prepare the data.
right,
I mean, we just took like a big folder from you without even
yeah,
really like talking too much about it and dumped it in. But I've been finding that if you wanted to track pitches better, you could do a test after you make the model and just do all the MIDI notes all the way up.
right.
Some of them are gonna like not work at all. Like it'd be like, oh nope, D sharp, no thanks. I'll go round down to like just a C, like
You have never used D sharp in all of
yeah.
your music.
But if you want it on the output, then you're
Right.
kind of out of luck.
Yeah.
So I'm finding just randomly changing the pitches when you go to train it. That can help quite a bit.
That's what
Um,
I remember.
yeah.
Rob doing so, or well, the that concatenative non-negative matrix factorization or whatever. That all of those things, like the best way to get pitched stuff was to like go to like take all your data and repitch for every semitone in an octave or something, and then you're more likely to get like all the to be able to generate all the different notes that you wanted to generate or whatever. On that,
Exactly.
yeah. Actually, so this kind of now it's making me think of my current project. So it I was kind of curious about like one of the problems that I've run into training my own vase is I think it's mode collapse where like
Hmm.
kind of like what you were talking before, right? Like of it just kind of finds one decent solution and then and then it like won't find any like it's like it just kind of solos in on one part of the distribution and then just gives you that no matter what you give it as input or whatever.
Yep.
Is that the same thing as what's happening with these models? Like, because from what I know, Vs are like pretty prone to mode collapse. Is that like something that you think about when you're preparing data, or like, is this the type of problem that you're getting, or is it something else? Or
Okay, so yeah, mode collapse isn't specific just to Vase, but because Rave has this adversarial training, which
uh,
means there's a neural net that's trying to classify if it's real or fake. And then the generator
oh,
is trying to generate the realist examples, but the
okay,
classifier looks at a random selection of generated and original Woog music, right?
right.
Um, so the mode collapse happens when the generator finds one thing that continually tricks the classifier. They're playing this adversarial
Uh,
game of the classifier's trying to find real fake, and the generator's just trying to convince it it's always real.
right,
So it becomes more real, and this is from a GAN or a
right.
generative adversarial network is like where this kind of adversarial training kicks in, and can create this mode collapse. And what mode collapse means, I mean, the really simple example of like numbers being handwritten, like 1 through 9 digits. The generator might just always generate ones because it's
Right,
like, well, I could always trick it if I do this certain thing, and like that's a high enough percentage of
right.
success that
Yeah.
like what I'm told to optimize as a fake generator, a forger, um, that gives me a good enough score that I'm happy with that.
Right.
It's better than random, right?
Is this the
It's better.
same? Is this the same sort of thing as like when it gets stuck in a local minima or whatever, like when the gradient? I don't know if actually. So this, I watched a bunch of these like kind of preliminary intros to neural networks and stuff a while ago, and everybody was talking about stochastic gradient descent, and but now like whenever I'm making one, I don't use SGD in like a it's like I'm usually using Atom or actually usually
Right.
just using Atom, right? So and I don't know if that method differs from the kind of or like how it differs from the gradient descent, but this sound to me it sounds a little bit similar, right? Like you get to this, ones are close enough to all the other numbers that it's sort of like, wow, that's as close as I can get, and I'm getting a decent loss or whatever. Like there's no way to optimize out of that. Do you think that's the same thing, or I mean, now we're kind of into me just speculating wildly. Is that the same thing or no?
Interesting. I guess I can't say theoretically that I know a very clear explanation of this, but the problem is that there's two gradients because we have two neural networks,
Right, right. The
and
Vey
and
and the
they
GAN. Okay, okay,
together
yeah,
they
yeah.
get caught into some trap together
Uh,
between the discriminator and the generator. Um, to your point about you know, gradient descent, stochastic gradient descent, which is kind of like the plain old version of it, where you're just skiing down a hill
mhm.
and you're just trying to get to the bottom. But maybe you're in a valley, and if you could get over this little bump, there's actually like a much deeper
Yeah,
descent
yeah,
that you make to the true like sea level to really get to the bottom. Um, and so you mentioned atom you use more often.
yeah. Mhm.
That adds something called momentum. And
Right.
so
Okay.
yeah, it's kind of like, oh, I'm down in this valley, stop would be stochastic gradient descent. But then momentum is like, hey, this has already been working. Let's
Let's
keep
see what's
going and
okay.
explore a little bit uphill. Um,
Uh-huh.
and something called saddle points, right? You're like in a valley between two
Mhm.
hills. So the momentum, just like being on ice, like it helps you kind of just skate out of there.
This is turning into a wonderful Winter Olympics metaphor over here. Yeah, cool, cool. Okay, that's interesting. Um, you mentioned earlier when we were talking something about latent diffusion with the is the latent diffusion thing a part of Rave? Do you want to also explain what it is maybe? And is it
Oh,
a
right.
part of like Rave 2 or is it uh something else that you've added on or what's going on with that?
Oh, yeah. So diffusion first.
Mm,
It's used in Stable Diffusion, the generator that makes images from text. And what that does is it learns some kind of filter to go first. It adds noise iteratively, and the neural net learns that. But then it learns the reverse of going from noise back to removing that noise. So it's quite similar to a filter that's learned, and that's the diffusion process. So you could apply that to images. You could apply that to a spectrogram, which is what the tool Refusion has done. It takes Stable Diffusion and it makes it work on fine-tuned audio spectrograms.
mm,
So then you're in this two-dimensional time and frequency space. Um, and you have all the pitches that are generated like patches of images and then turned back into audio. However, then you have Harmony like is working on dance diffusion. They have this product kind of like freely available for anyone to hack with. And our buddy Hexosismos took Rave, took dance diffusion, which works on raw audio,
mm,
and then made it work for the encoded VAE space. So first you put your audio into Rave and it encodes it kind of like an MP3 can,
mm,
compress, but this is like a neural compression that puts it into this space called magical latent space. Those sequence of numbers, it's much smaller than audio samples.
mm,
It's like one set of like 16 channels, but it's like per like so many milliseconds. So it compresses time and the actual amplitude together
mm,
and creates some way to encode that. Then this diffusion, rather than going back to pixels or going back to raw audio, it goes back into rave latent encodings.
Oh, that's
And
such a nice idea.
it's so cool, right?
Yeah, I
So
love
it
that.
learns to generate chunks of rave latent encodings. And I trained my first one this week on CJ and me doing throat singing. We recorded an hour of ourselves reading through like one syllable, two syllable, three syllable dictionaries. So we had like
Amazing.
every type of sound, like ah, e, o, u, yeah. These types of data sets. We each made one, trained a rave model, and then put our data set through that to get the latents. And now we train the diffusion on the latents, which gives us a time series that can be
Right.
decoded through Rave again. It sounds pretty cool.
That's such a sick idea because I feel like, I mean, I don't know if this is true, but like I well from the other models, so for example, like the diffusion sort of stuff like refusion or whatever,
Yep.
from what I've heard, it has a hard time with like time coherence, where like there
Mm.
is not always, but sometimes it'll have a hard time like stringing longer sections together. And yeah, this seems like a kind of a no-brainer for like a way to, well, not a no-brainer. Obviously, it was hard to come up with this, um, but like this seems like a really great solution to that, where there's like this kind of better chance of making those time series things work on a larger scale. It's funny because I remember like remember that jukebox AI thing?
Mm.
I
Oh
remember
yeah.
looking at like the release of that, and they were talking about how they have like layers of variational autoencoders. So you have like they were saying something about like to get that kind of time coherence thing, they would train uh like not sure if I remember exactly what they were saying, but something about like, you have like the encoder for the first one, and then that gives you this sort of like point in n-dimensional space, like in the latent space. And then they would have a couple of these like the time series points as the like the movement through variational or through the fucking latent space. And they would train a model on that movement and then train a model on that movement. You know what I mean? And then you have this decoder that has all of them in a row or whatever. So you get this like each kind of point on the middleist layer gives you this like longer transition through like the latent space up, and then a even longer transition on the latent space above that. I don't know if that's what they meant, but that's what I got out of reading about it, and I have been obsessed with that idea ever since. Like that's been kind of my like goal for the AI stuff that I've been doing, is like it just seems like such a clear and good way of getting that time thing to work nicely. Um,
Right. Yeah. Long-term time dependency is still one of the limitations. That's like
mm,
open question, I would say. I mean, we're getting closer, but there's different approaches, right? Like, do you start top down, structure, phrases, notes,
mm,
timbre? Do you start that way, or do you start sample by sample?
mm,
Sample, build up to onsets, build up to sequences of onsets, like phrases of notes, build up to sections. Which way is better? And
yeah.
we started with Dadabots started with sample RNN, and that started bottom up. So we
Mhm,
started with predicting little samples. And what you're talking about here is like this dealing with scaling. So we
yeah.
have in Jukebox, you start with these. This is called VQ VAE, or vector quantized variational autoencoders, and there's different scales of them that feed into each other.
Mm,
So you end up with a code book. It's called that learns it's quantized. That means code book, right? So it means like you have a vocabulary. It's based on like language modeling, and actually sounds are the vocabulary, and it learns how to create all these certain types of sounds as the code book. But then at the structural scale, it has a code book, and then that feeds into um, sort of more of a phrase, and then like a detail high resolution to get a higher sample rate type scale. That's how those work. And there are other ways you can do that. whether you use something. I used to use something called catch a waveform, and that just started with the audio, and it started with bass frequencies. So it
Oh,
has,
interesting.
yeah, it just has like the low frequency, right? Because like that's like a low, like if you do like 300 hertz, that's a really low sample rate if you only need
Right.
300 hertz. So you can start with low sample rate and then
This
feed
is
that into
interesting.
another
Yeah,
scale with another GAN that's like, oh, I'm 400 hertz. Okay, now 800 hertz.
right.
And each of the previous scales conditions the next scale. And it's like
Mm.
given this input, all right, generate something more realistic at the higher frequency.
That's
Um,
so interesting. I love that idea.
yes, there's hierarchical approaches, and you're
Mm.
totally right. Using hierarchical approaches for music, because music has a lot of long-term dependencies,
Mm.
it's really valuable when you're using this raw audio stuff. A lot of it comes out of speech synthesis, and you just need a couple phonemes, and then like condition it based on like what was the thing I'm trying to type to to do like text to speech. We extended a lot of this stuff for music, and a lot of times having more of these scales or tiers or layers kind of help this way.
Mm. That's yeah, cool. That's very interesting. It gave me kind of a lot to think about. I was gonna ask also, do you train the the latent diffusion part at the same time as the rest of the rave model, or is that something that you train on like the final kind of like once you have a learned latent base, then you train it on that?
Yeah, exactly. It's later, so you can have your rave model fully trained, and then you can train it this latent diffusion on it. So it's kind of like first you have the encoding, that's the rave encodes and decodes. So you have this machine that can compress your music and then decompress your music, and you use that machine to learn a series of the latent codes by what using whatever data set you want to pump through it.
Mm.
So it can be all done after the fact that you've trained the rave models, which is pretty cool.
Yeah, that seems kind
Because
of handy.
yeah, like so Antoine, who it was at Ircam who made rave, he has something called MS prior, and prior is this kind of like academic word from statistics, Bayesian statistics, that just means it's like your time series for us. That's how we're thinking about it, right? It's like here's our long term like music that we want to generate. Like we already know how to encode some stuff, but what is the actual audio over time? What's the composition over time? What's the structure over time? But he's using something called a transformer, and transformers are different than diffusion.
Mm.
I haven't quite explored his stuff yet. To be honest, I just ran into some errors on his code, and I'm stuck in that like terrible error loop. Like asking ChatGPT, what does this like, what does this traceback mean?
I feel like that's like it's so funny because so much of, for me at least, my experience of most of my experience of trying out other people's models has been a lot of that and very
Yep.
little like getting it to actually work. And so many times I've been like, oh, I want to really want to try this thing, and then I try to download it or whatever, train it or whatever, get it set up. And then by the time I finish all that, I'm like, I don't even fucking care anymore. Like that was such a
Right.
pain in the ass.
Right.
Yeah.
Like, oh, a month ago I was trying to make music, and
Yeah.
I'm still just like messing around in the terminal.
Do you remember that? I think we talked about this when we were hanging out in Boston, but that that old like music producer forum meme of like I was like, oh, I was trying to make music, and then I thought like, making using drum kits is kind of cheating, so I made my own drum kits, and then felt like using samples was kind of cheating, so I started recording my own drum samples, and then kind of felt like that was cheating, so I started building my own drums, and then kind of felt like using pre-made skins was sort of cheating, so I started skinning my own goats, and then the anyways, I don't have to do the
Yep.
whole joke. Although I love to tell that
Yeah,
one.
it's very very relevant, right? It's like, oh,
Yeah, that the like dependency hell or like yeah, the errors and you don't know how to trace them back or whatever. It's oh God.
Like oh, I
Um,
wanted to use Jukebox, but then that's just OpenAI's pre-trained data set, and none of my friends' music is in Jukebox. So then I started finding tuning Jukebox, and then I realized it didn't sound very good, and then I just started training Rave on everything from scratch, and then I
yeah.
realized Rave didn't do what I wanted to do, so I made my own architecture up. And 5 years later, I'm like watching MIT OpenCourseware videos and not making any music. And my
Yeah.
skills have atrophied, and I have blisters on my fingers when I play the guitar.
Yeah, yeah. Oh God. Relatable. Actually, that kind of brings me to another question. Like, so, um, you mentioned training, kind of before we got into this meme tunnel or whatever. You mentioned training your own models. Uh, do you always train from scratch, or is it like semi-common to have like a base model or like I know a lot of these bigger architectures have like base models that you fine tune off of, and I think I've seen some stuff like that for Rave or Stable Diffusion or whatever. But is this a common approach that you use, or what are your sort of thoughts on this approach? When is it good? When is it crap?
Oh, totally. The great thing about pre-trains would be that it was so expensive to train that they used like 500 GPUs for like a month
Mm,
on a million songs. And that can give you a really great understanding of how different genres are similar and different. And this is how Jukebox was trained. Since
mm,
we've been talking about Jukebox, for example. Um, the thing about Rave, I haven't really done transfer learning with Rave too much. It's often called fine tuning or transfer learning when you do
mm.
this. It's really focused on smaller data sets. And
Ah,
it's possible to transfer, but training from scratch, it usually gets a better model. So the only reason to really transfer would be to save time,
okay.
because it could take a few days. But the only time I really do this is if I might train my own like Wogue model, and it'll be like, wow, like the D sharps don't work. And then I'll augment to make sure that there's some like artificially pitched D sharps in there,
Mm,
and then I'll train a little bit longer beyond like the normal training time, and that's a shortcut that can like kind of salvage some of your models that you
right.
thought were failures. um Riv, it trains fast enough if you use like a collab notebook or any GPU that's like available either through cloud or your own machine. So it's usually easier to just train from scratch. The advantage of transfer learning would be if it was pre-trained on thousands of artists, and
Right.
you just want to say like, "Hey, hyper focus on this one style," um, even though you
So,
have like a vocabulary for like all the music ever created or something,
so would you say that like transfer learning or fine tuning or whatever is mostly meant for like kind of zeroing in or like adjusting the distribution that it's already able to model? Is that like the main place where you find it useful or because my kind of conception was like that, you train it so far in one direction that then trying to pivot in a different direction would have like a different result, not necessarily favorable, but a different result from like just going directly to that kind of endpoint from the
Right.
get-go. Does that, I don't know. Yeah. Anyways, go
Yeah,
ahead.
exactly. It makes so much sense that we would have some kind of like curriculum, and they even call it curriculum learning.
Mm,
They've tried to explore this a lot. Is there a way to teach like the fundamentals, like
right.
grade 1 math, and then you go to like grade 2 math, learn multiply, and you learn like calculus? Like, shouldn't computers be able to level up by starting with simple things? But it's difficult to figure this out. There's a whole branch of like reinforcement learning to figure out how to like continually learn over time,
Right.
and stuff like that. When you're doing this supervised learning though, where you're just saying like, here's a data set, imitate the data set, it tends to organize, the net tends to organize itself when you just show it everything,
Right.
all from the beginning. And it's kind of like an open problem too, I'd say, in the research
Okay.
still.
Interesting.
So it sometimes it works to salvage your model again, but the idea of fine tuning means basically you have a model that's a generalist. It knows a little bit about everything that you care
Mm,
about. And then you want it to be a specialist. And that's when you fine tune.
okay.
So the generalist models are really powerful because they can bring things that aren't part of the original artist. So
Right.
if there's a general model that's trained on like 7,000 artists, I'm like, okay, but now focus on Wold music. It'll be a lot like Wold, but it's cool because it will bring in hybridization of your music
Right.
from other sources that training something like rave from scratch really won't have as much capability to do because it's
Mm,
never seen anything outside of you. So
right.
that's when fine tuning's great, and it's great when big companies make those available.
Yeah.
Like I don't know, there's like Google language model and some new things that haven't been publicly available. So it's not always, it's sometimes locked up in those companies that spend a lot of money and time to build those
Mm.
too. So I think this more coming for the future. Um, right now, it's still probably easiest to train just on one specific set of things that you're interested in, unless you're really interested in like hybridizing different genres together.
Someone's got to like hack a Bitcoin farm or something and just use it as a server farm for training LMs. Or, anyways, sorry. Nobody should do that, officially speaking. Do not. Anyways, but if you do, call me. But don't do it. Um, I was also, that kind of made me think a little bit about two things. One is like the reinforcement learning thing, um, which I want to get to. But the other thing that kind of made me think about it, did you ever hear about that like Waluigi paper about like the it's like this. So in these like large language models, it's this sort of theory that that you have these synthesized agents, and when you are talking to one of these models, that you're sort of like connecting to one of these agents. And the Waluigi idea or whatever is that for every Mario in your data set, there's like a inverse agent. So the Waluigi of your, I don't know why I said
Oh,
Mario. Luigi and Mario,
Luigi,
not
yeah,
Mario and Waluigi. Wait, what am I saying? Luigi and Waluigi. There we go. We got it. We got it.
yep.
Um, yeah, I don't know how much I buy. I didn't read the fucking paper, but I don't know how much I buy into this idea or how applicable that is or would be to these kind of smaller models. But it makes me kind of wonder. It also kind of makes me wonder about something that I think Rob Clouth was saying like a long time ago of maybe it would be interesting to try to get a model where you train it on one thing and then try to generate the inverse of that thing, whatever that would be. I don't know how you would kind of do that in practice, but I don't know where the fuck I'm going with this. What were we talking about? Uh, right, fine tuning. Hmm. Wait, but okay, okay. So that wasn't a question, I guess. I thought it was a question, but in the end,
So it's like alignment, right? You're talking about like
yeah, yeah,
how to
yeah.
take a large model and align it towards something.
Right.
And I actually haven't read this Waluigi paper. I just pulled it up right now. I'm assuming this is like the shadow self, right? It's
Yep.
like the
Yeah,
shadow
yeah.
work of an AI or something.
Right. I think like from what I understood, I like listened to a podcast where they talked about it, and from what I understand, like they were saying th they weren't sure if this was because narrative structures, when you have a protagonist, the antagonist is often like the inverse of the protagonist, and that's why this
Mm.
kind of like inverse agent, this Waluigi, like shows up in the models. Um, but yeah, I don't know. Do you think this is something that like could like appear in a music model or like I don't I mean I would like to try that, but I don't have any kind of conception about like what would it mean to generate the inverse of whatever distribution it's trained on. You know what I mean? And
Oh,
would
totally.
that even make any sense or would that just be sort of nonsense data?
Yeah, I think if it's purely just audio, it could be nonsense data. But if it's conditioned on text, our text has
Mm,
meanings. So we have like antonyms or opposites. We have low and high and shiny and dull, and we have all these like concepts that language abstractly represents.
mm,
So it's supposed to have this like co-occurring latent space where you have like all the audio is in a latent space, all of the text is in a latent space. We know the semantic meaning of what all these words mean. We know what all this audio, how this can all be combined. And then they have like a joined latent space where, they occur together, where bright and some type of genre of audio occur, maybe. So I think when you have it conditioned by text like this, or when it's a sequence to sequence, like text concepts into audio concepts, this can exist. With pure unconditional, it's a little bit more, like you said, like, what does that even mean? Like,
mm.
if I play a snare drum, what's the opposite of a snare drum? Like white noise? I don't know. Just like everything outside that spectrum, right? It's
Yeah,
like a little bit
yeah,
too abstract. Like music itself is really, really hard to define in
yeah. It
spectral
is very
terms, right?
abstract. Yeah. Actually, okay,
So
that. Wait. Oh, sorry. Keep going. Keep going. I didn't mean to cut you off.
yeah, so I just think that like maybe amongst text prompting models, this makes sense in language models like this. I have a really hard time even answering the question if it's just an audio model, though, that has no
Right.
concept of how to condition that based on our ideas and language and stuff like that, that organize it a bit more.
Right. Yeah, no, I fully agree with you. Something that kind of made me think of, and I want to get back to the reinforcement thing, reinforcement learning thing in a second, but something
Yep.
that made me think of is like the um so like it seems like you and Dadabots specialty is sort of like raw audio neurosynthesis, right? Like the generating the raw the samples the sample values themselves, right? Um, I wanted to kind of get your thoughts on like, well, I guess I've always kind of wanted to ask you why is it that that is the most interesting to you? Like, why is that the one that you guys have kind of been pursuing this whole time? And also just kind of open up the floor to your thoughts on symbolic methods or other like kind of transformations of the audio before and after or whatever.
Yeah, I think that we started this path on raw audio because there was a lot of work on MIDI already, or
Hmm.
score generation. And, there's like David Cope had, used Markov chains back in the 70s to make fake Mozart compositions. And we had already achieved quite a bit with symbolic because it's kind of like a more compressed form of media already, right? Like there's already
Hmm.
a lot of information in MIDI that raw audio doesn't have, and a lot of the music we liked drew us away from generating Bach chorales. So I think when you want to have like 4-part harmony, yeah, MIDI is the way to go, right? If you want to
Hmm.
generate something like that, a fugue, probably MIDI is the way to do it and not raw audio.
Hmm.
We were interested in free jazz, noise, glitch, black metal, death metal. We were interested in math rock and crazy stuff that the production was so important. The guitar tones were so
Yeah.
important. I don't know. How do you make hyper glitch with general MIDI? Like, I guess it's more like black MIDI than like.
Been ongoing research question for the last 10 years on my side.
So it's like, yeah, there's no like Merzbow with MIDI. Like
Right.
there's certain genres that just cannot exist with MIDI.
Mm,
And so we felt like this was completely being overlooked by like the current academic climate when we started in like 2017. So our first paper was beyond Bach, Beethoven, like generating black metal and math rock,
mm,
because we wanted to create all the crazy sounds that we were inspired by. I mean, I saw a question here about could we like use raw audio and like deal with the dependency issue by having some chord progressions that were like, hey, these are all the chords here. Here's a harmonic analysis. And you touched on this earlier with like chromograms or like other like spectral
Right,
analysis of like different parts of the spectrum that has music information that's like more human intuitive. And I think there's a lot of space to combine them, especially as a way to control the more raw audio generative stuff. But you'll never really get beyond having to synthesize everything later if you can't
right.
get to this raw audio step, and that's why we focus on it.
That's really interesting. I feel like I have the same kind of like tiredness of Bach chorales. I mean, it's hard to enter the space from like a music production standpoint without like coming in and being like, why is everybody generating Bach chorales? Like, what what's the deal with the Bach chorales thing? But yeah, I don't know. My intuition was also that like, um, and that's kind of what led me to this current project that I'm working on, where I'm trying to control an like operator, the FM synth in Ableton, with a neural net. Like I'm trying to like learn the parameters of a synthesizer. And my thought on it was sort of like that learning from the audio, like the raw audio itself, just seems like such a crazy huge task. I mean,
Right.
in a way, to me, it feels like the same idea as like what uh what these large language models are showing that you can do. Like if you just train on fucking everything forever, then yeah, eventually you get some really, really cool behavior, some really cool results and predictions and stuff. Um, uh, yeah, that's really cool to hear that you kind of arrived at that in the same way, like from the same kind of insight and reaction that I had, but I just ended up somewhere else from you. Um,
Totally.
this goddamn Bacurals. Uh, um, okay, cool.
Like,
Yeah, it kind of makes me think also about like, you know, I don't really know how to phrase this question, I guess, but like, you touched a little bit on the what were you the chromographs thing?
oh yeah, a chromogram is just
Chromogram, right? Sorry.
it's like the pitch energy. So if you like take all the pitches across all range of your spectrum,
Hmm.
so you align it um in a CQ, it's called a CQ2 constant Q transform. You take a spectrogram, constant Q transform it, which is kind of like a MIDI roll of
Right.
spectrum. It's almost like a phase vocoder or something, where you
Hmm.
can have like pitches that control certain bins. And then you collapse it down to one octave, and that's called a chromogram. So you have A through G sharp, and you have the amount of energy that's in any of those pitch classes
Right.
for every frame of the analysis.
Yeah, I think I've played around with this a little bit. There's some like thing for generating those within some library and Max that I was playing around with.
Yep.
It kind of makes me think also about like, we were talking about, you know, the Waluigi thing, the inverse of whatever sound. And that kind of got me thinking about like, I think it was from Earcam, they had like these audio descriptors of like the
Hmm.
amount of skewness or like kurtosis mean or
Oh yeah,
whatever. Like
yeah.
there's all these kind of like interesting kind of descriptors that they came up with, and I feel like from that perspective already, like without the language part, I can kind of start to imagine what it means to have like the inverse of a sound. But
Hmm.
I don't know. I mean, that's one kind of lens. It feels like I don't know where the fuck I'm going with this, but that I guess the problem I can kind of imagine from that already is that the inverse also depends on what your sort of like basis is. So like if you have a point on a graph here, then you could say that the inverse is here. But if your graph is like tilted like this, then maybe the inverse would be over there or whatever, right? So like
Right.
your basis kind of makes a difference for like what the inverse would be in that sort of setup. And then
Yeah, like what are your
yeah,
dimensions that
yeah,
you're
yeah,
inverting, right?
yeah, yeah,
Like
yeah, exactly.
are they things that are like kurtosis that's like what the hell is that? That's like a statistical thing about your like peakiness of your distribution of a
Yeah.
sound. Like it's so unhuman and unintuitive to think
Mm,
about. It's not how we go to like a producer and we're like, oh, like make it bump. Like no, like like what is that kurtosis
right.
exactly? And like who knows? Our again, I think music is so abstract, even more than image. And when we do text to image, and we're like, give me a picture of a chinchilla balancing on top of a ball,
As we
like
all
eating a
do.
cake, right? What like does music even have that type of that's actually language describes a description of an object and a scene pretty well, but I feel like people have a lot of discrepancy about how they perceive music, and that's why we have like all these music critics who like use all
Yeah.
this like crazy flowery language to describe music,
Yeah.
and there's no like objective way to describe music. So I'm a little skeptical of like text to music
A
and
hundred
what that
percent.
even means.
I feel like it's funny too because I feel like anybody who's ever worked like with a client on any sort of like music production or music creation project knows already like how brutally like inaccurate people's ways of talking about music are and how like non-specific and how there's a lot of this kind of like guesswork like part of your work as an artist if you're working with a client is like trying to figure out what the fuck they're talking about because they don't
Exactly.
fully know, you know what I mean? Like it's like this weird deduction sort of game. Um,
Totally. That's what I'm trying to say. Yeah. You got
yeah,
it.
and it's funny too that like yeah, I wonder if there's gonna be this sort of yeah, there's a lot I guess there's a lot more space for like also the general public to be like this isn't fucking working because their kind of understanding of the term and I don't know, it's like a really that's a funny like that I never really I mean, I guess I thought of that, but not in those terms before. Like the like yeah. No, good point about the descriptors and then also like language, how it relates to sound and the abstractness of sound and yeah. Fuck. There was something else I wanted to kind of follow up with you on that. And it's gone. Okay. So um I guess that brings me back a little bit to the reinforcement learning thing.
Right.
Um, so okay, I want to kind of come at this from two different sides because like when we talked briefly before this chat, you've mentioned some really interesting kind of other ways of doing machine learning. Um,
Hmm.
and like kind of as we get into that, uh, the little thought that I had that was kind of triggered by our earlier conversation was like Um, they have like they do like RLHF for like those big language or at least the GPT or the Chat GPT or whatever those GPT-4 or whatever models are like they use RLHF for the fine tuning. Um, so reinforcement learning with human feedback. Um,
Yep.
I wonder if there's something about that idea that really sort of appeals to me, especially in the context of music, of like a way of doing fine tuning. Do you feel like this is something where, I mean, I guess what you were talking about with the this is it sounds like the RLHF is sort of like this abstracted away version of the fine tuning process that you were talking about, where you have it model a certain distribution and you kind of focus in on like, okay, we have a data set that like better represents the specific area we're trying to target, and then you train it some more on that. Um, yeah, I don't know. What are your thoughts on that? And I kind of open up the floor to you to talk about other types of learning.
Yeah, so I guess it's like a human in the loop.
Right.
So you've got some stuff the model's pretty confident is right, and that just probably shoots out as like this is good, and then it gives some examples to humans, and that could be a system where you have a human or like group of producers or artists who are like, okay, give me these descriptors, like give me music that's like this song, but more with like I don't know, like trombones and then it's like, hey, is this like a trombone more? And you're like, no, 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 that's
Right.
more like a violin. Like go the other way.
Ah,
And it's like, oh, okay, wait, so more like this. And you're like, no, yeah, this one. And it's almost like that optimization, assistance where like you're starting to give supervision to how it's learning over time
mm,
by giving it more examples of
right.
what it's failing at.
Right.
So I think that's the basis of this kind of idea, human in the loop approach,
Right.
and how
Right.
would that be applied? I guess I could think of two things. I could think of like a live stream where the chat is steering it, and we have a neural net that's learning in real time from the audience,
Mm,
and it's like no, no, more like this, and it's wait, oh, do you mean like this iteration? And it's like no, 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 like the first one was better. You're going the wrong way.
mm,
That could be one thing. Maybe you just have a person like a producer, and it's really a quick process where like you train a model, it gives you some output, and you're like steering it the way that it should keep going with the people in the studio with you,
mm,
being like, no, no, make the album more like this, and
right. Right.
you steer like the generation of some sections together. Um, so these are, I guess, a little bit more in the future. We don't really have these systems yet, but they've been applied to other things,
Mm.
and it could be applied to music too.
Yeah, that kind of like, yeah, uh, what you said made me realize that I guess I sort of like misrepresented the reinforcement learning part of that because it's like usually you would have an agent and then some sort of like signal, like some sort of reward signal or whatever, for
Yeah,
whether it was doing right or not. Um,
yeah, and I
yeah,
guess what, like another reward, if it's autonomous, it makes a SoundCloud account by itself. It starts putting out tracks, and it's
yeah,
like, let's get the tracks with the most comments that are like, oh, sick drop, and then like the most likes, the most reshares, and you're optimizing that. And it has some objective of like, get in the top 100 on SoundCloud or
mm,
something, and it just figures out how it can do that by raising up, and that way it figures out its own objective that okay, likes aren't that important if people are commenting and sharing my music.
right.
Like a like is kind of like shallow. It can learn those things on its own. The more like basic approach to reinforcement learning is more where you tell it, exactly which parameters to optimize, which like measurements to optimize.
Okay,
Um, but it can be very difficult to teach. That's kind of like one of the challenges in reinforcement learning is teaching it to know its own rewards,
right.
how to reward its work the best, and move towards that direction. And I guess this is like one way we could have really dystopian, horrible, like cookie cutter pop AIs that are
Yeah,
just like
yeah.
trying to like maximize making money for like Universal Records or something.
Right, yeah, that was the thing that like immediately jumped to mind at like how good those reinforcement learning models are of like finding cheat codes and like
Oh, right.
sort of like breaking out of the box or whatever. That's what I've always found so fascinating about them is that like they if there's any sort of crack or like you're not your objective function isn't like exactly what you like transmitting the message that you want to be transmitting to it, then it very quickly finds like a workaround and then and then optimizes on that. Yeah, I had this
Totally.
idea a little while ago of like using just a video with sentiment analysis and that being like the objective function was like how happy do I look when it's playing the music? And it would just like
Yeah.
play music and then if I liked it, I would be like, good.
Oh, that's
Um,
cool.
I I thought it would be funny also. I mean, I don't think this is possible with like the s scale at which this kind of training usually like the length of time this kind of training usually takes because like reinforcement learning is usually way longer than uh these like unsupervised or supervised methods if I'm not I'm right in this, right? Um Anyways, so I'm just gonna
Yeah,
continue.
they're kind of continual. Yeah, they're kind of
Yeah, yeah.
continuously learning, right?
So, but yeah, I think like that's not really feasible to do it on stage, but it would be really funny to have like a show like that where over the course of an hour you're watching like an AI get better
Oh,
at playing music and the person's just sitting there on the stage like
oh, yeah, I love that idea. Yeah, so it just becomes like a game of like Britain's Got Talent or like American
yeah.
Idol, and you're just like the judge, you're just like Simon Cowell, with like, you suck.
Boo. Um, yeah, I guess y like you mentioned some other stuff that you're interested in. You said something about neuromorphic computing, and I guess we kind of
Yeah.
slightly started talking about continual learning. Do you want to tell me or tell us more about neuromorphic learning and what you're interested in that, or what's getting you stoked about that?
Yeah. So this is something that might never work, but it's cool. It's inspiring the algorithms by things that could be feasible that our brain might do. Right now, we have this way of training neural nets called backpropagation, where you push data through the neural net, you look at the result, you look at what the original data was, and you look at the difference, and then use this thing called the chain rule of calculus to go and like tweak all of the weights in the neural net, and it's like this forward backward pass thing that happens when you train a neural net. But our brain probably doesn't have back propagation in it. It doesn't compute all the neurons, look at the analysis of what the input and like the model was, and then tune by going back. It probably doesn't have access to that. It uses something more similar to, it's spiking. So we get like these energies that are like triggering events, and they have a frequency on all the neurons. And that's what neuromorphic computers is trying to do. It's called reservoir computing sometimes, because you can think of it like filling up buckets, and when the bucket spills, you get a trigger that shows, hey, something happened. And then
Mm-hmm.
now you're measuring the distance of how frequent these buckets overfill.
Mm-hmm.
I'm really into it because you could take something like a recurrent neural net, and you don't even have to train it. It could be completely random. And the way that recurrent neural nets work, they have a bunch of nodes that are connected to other nodes, and you just randomly connect these. And there's all these different patterns and paths that it can take to get to the end. And so there's a lot of complexity in the randomness of an untrained net. And what it does is you take a final layer and you just do a logistic regression and try to learn how to find a good path that actually represents your data just by going through the untrained paths.
Oh, wow.
It's crazy. And um, so there's two things I'm interested in. One's called a conceptor, where you can kind of cue a recurrent neural net to replay certain things, and then you store these. They're almost like samples or like presets, and you can store them all. And the cool thing is you can do Boolean logic with them. You can say like sound A minus sound B plus avoid or do sound C if the other two don't work. And
Mm-hmm.
you can do all this crazy logic with the latence, rather than what I was talking about before with diffusion. We're just trying to generate a likely sequence of them. Here you could actually have a lot more control, and it works very quickly because you don't have to train the neural nets. They're
That's so
untrained.
interesting.
So it's more like how our brains work. It's very quick, and it might be a cool way to learn performance um, mechanisms and things like that about how we want to perform live, even. So
Right.
yeah, I'm interested in training rave latence on these as well. I've done raw audio, but it's the problem is it again, long-term time dependencies is pretty limited to like I've only been able to get basic like 808 drum sounds so far. So maybe with
Mm.
rave latence I could do more.
Yeah, that sounds super interesting and like lots of potential. That's a wild conception of like how to do that. I feel like I've heard a little bit about this like this spiking or uh like that term in particular. I remember I again, there's some other podcast that I was listening to where somebody was doing some research on this like spiking thing. The other thing that kind of comes to mind is those like the forward uh models or whatever that's like an
Right.
alternate version of that's not the same thing, right?
Well, it's an alternate to backpropagation. So
Mm,
it is trying to find new ways to learn to train neural nets. Yeah. It's this pursuit of like what works other than backpropagation,
right, right. Is that like a
something
really
more efficient.
active field of study right now? Are people like, goddamn,
Not
get rid of these Bach backward
not
propagation corrals?
not really. Not really. It's not very active.
Mm,
I just think it's cool and I like to learn
mm,
things that people aren't really working at. Usually they just throw more GPUs at it and that's it. And
right,
they're like, I'll deal with the compute.
right, right, right. Interesting.
Hell yeah.
Um, yeah, that was very interesting. Um,
Been amazing.
yeah, I think that there's like lots of interesting potential in those kind of yeah, like alternates to what we're doing or I mean, so I guess this is kind of why I think like what you're doing and like just this there was another thing that I wanted to talk to you. Hey, we're segueing into it very nicely. So,
Nice.
the there's something really great I think about the way that you and uh other people who are kind of like looking into these ways of making these kind of like smaller models that are more accessible for people to like train their own or
Mhm.
whatever. Um, I wanted to get your thoughts a little bit on like the different sort of sizes of models. Like of course we have these kind of big corporate models that take millions or whatever billions of dollars to train, and then we've got this kind of like in between where you've got a bunch of these like open source kind of organizations or whatever training these kind of in between sized models, and then the kind of scale that you're working on, and then the more old school method of doing like a really, really small ones. Uh, yeah, do you want to like just talk about like your thoughts on that, and also like do you think like there was that paper a long time ago of like m- the bitter lesson or whatever, where like more data is always better.
Mm.
I don't know. Yeah, what's your thoughts on this?
Oh, I love this question. Can we take a quick commercial break and I'll be back in
hmm
like 1 minute? Quick bathroom
Yeah,
break.
let's take a good like 5, 10 or something. Let's
All right,
say
cool. I'll be back in a
ten
second.
ten minutes. All right. And I'm gonna put on like a pause screen and play some music and turn off my mic. Yeah, see, I gotta load this shit and I close my playlist, so you gotta listen to me sing for a little bit. Ooh, ooh, ooh. Okay. Back in yeah, I'd say back in what did I say? 10 minutes? Back in 10 minutes. So right now it's 5:18 here in sunny Montreal. We'll see you back at 5:28. And we're back. Just wanted to say that again for the recording because I forgot to unpause. Um, right. So thank you everyone for coming back from the break. Let us continue on our discussion of sizes of neural networks with Zack from Dadabots.
Totally. Yeah. So I see like three kind of big patterns right now. You have the very large companies, Google, Facebook, OpenAI, Stability AI, who have millions of dollars of compute budget, and they're using hundreds of GPUs to train very large models that are either just about audio, just about spectrograms, or maybe they have some cultural elements, right? Like descriptions or text or genre or artist encodings that are part of it too. And that's like jukebox is like the example that everybody's had access to for a while and seen examples from. Jukebox can even do lyrics, and it trained on all this lyric data. And then, we have new generations coming out of those big models. It started things like VQ8, and we're seeing diffusion models that'll be coming out that'll be very fast. Traditionally, they've been so big that they've been slow to generate. Like Jukebox can take hours or a day to generate a song. Uh, Newer things can do it in real time, even with like large pre-trains like this. Then we have stuff that people at home can train on one GPU or using one Google Colab notebook, renting like a cloud GPU or something for, affordable price. Those things like Rave and even sample RNN, some of the older methods work this way. Within a couple days, you can get a model for an artist. I guess the final tier would be stuff that's CPU and not GPU at all. And so far, we see stuff with inference time that's CPU, where like Rave can be generated on CPU, but it has to be trained on a GPU. And then we'll soon be able to, I assume, train on a CPU too. And I think that's cool because then we could be learning more in real time. I think that opens up more reinforcement learning opportunities within like a DAW. And I guess I'm really interested in, generating very small snippets of audio even. I mentioned this neuromorphic computing, reservoir computing stuff that is inspired by the natural brains and how our human brains work. And it tries to use no backpropagation. So it tries to, only use what's available to it at the time without going a full pass forward through all the graph. And I think what could be cool there, I always see in chats people say they want, I guess, like something like Serum, like a wavetable synth, but neural, or
Yeah,
like granular concatenative, but neural.
yeah, yeah.
Um, right, like the sounds could blend together in
Mm,
interesting interpolations, interesting morphs. So I think there's a limit to the large scale text models, and you need a lot of data.
yeah,
And this doesn't even get into the whole like industry legal battle of like who gets to use all of our like, you know
right.
record label music and
Yeah,
like do
yeah,
we
yeah.
all get access to that or not. So it's really cool to have this idea of like personal AI, like AI that's just this small amount of stuff that I'm interested in right now.
Hmm.
Um, Figuring out ways to make that really good, I think, is really exciting. I really just like giving this stuff to artists and giving it to people to specialize on their data. And I feel like a lot of artists, when they want to hear what AI music is about, they might want just something that's in their world and then brings in some new influences or new permutations that they haven't heard.
Yeah,
So there's a lot of room for that. And if you had like a neural wavetable synth or granular synth, I think that's really cool. It's a simple application because you don't have to learn, the long-term time dependencies like we were talking about. You can learn like little tiny waveforms,
yeah, yeah.
and if it's in this neural space, the interpolation could be super compelling and realistic, and get interesting sounds that we haven't heard. So I'm imagining this emerging in the future as kind of the architectures, the algorithms get better to be able to handle those types of situations too.
Yeah, yeah. I really like a lot of what you said. Um, well, I liked it all actually, if I'm going to be honest. Uh,
Thanks.
yeah, the wavetable idea is so compelling to me. Like yeah, I can't it's funny because when you said that I was like, "Oh yeah, that is such a fucking sick idea." And I totally like haven't thought about that for a while, and it's a in a way sort of like yeah, I mean there's in a way there's like almost anything that you can kind of represent as a wavetable to a
Hmm.
certain extent, like there's some things that are um kind of like tricky in a way to have as a wavetable unless it's like a I don't anyway, whatever. But like um yeah, that seems like in a way this sort of shortcut to a lot. I mean, that's what made me interested in wavetable synthesis in the first place is that it feels like this huge shortcut to like a lot of different sounds. And the neural version of wavetable synthesis just sounds like even more of a shortcut to like all these amazing sounds. I remember when Google put out that
Hmm.
like that N synth or whatever, and I had all the
Totally.
hope in the world that that was going to be this amazing fucking thing, and playing with it was very disappointing. And yeah, like yeah, Vibers said hyped for neural effects as well. I also think that
Oh
that's a
yeah.
great, there's so much great potential there. Like actually, I remember thinking about this in terms of like convolution reverb and just like kind of convolution in general, that there's a lot of parts of your, so say you have like an effect chain with like it only works with like certain classes of effects, but you can, take an impulse response of your effect chain and then pretty or like perfectly model that effects chain just with one convolution reverb. Again, depending on the effects that you have in that chain. But um and yeah, there's something so kind of it also makes me think a little bit about like that guitar, there's like this guitar company that they what the fuck are they called? A bunch of guitarists have recently put out like their
Hmm.
neural audio. They've like put out their guitar tone through this
Oh,
app, and
totally.
then yeah, and then you can play and it generates that guitar tone of that artist or whatever. Um,
Yep.
yeah, there's so much like kind of cool potential there. Um, I'm
So
sorry, go ahead.
yeah, I got a link here. DDSP. I've seen people talk about neural effects and your idea of the guitar tone, or talking about that
Mm,
being created already. We've worked with a guitarist, Pliny, and he's got one of these models.
mm,
I believe it uses DDSP. So that's differential digital signal processing. So it's like
right.
normal DSP, but differentiable with this backpropagation gradient
Mm,
idea. And so you can learn signal chains, and you can do
very
that
cool.
with the neuronet now with DDSP library. So that's one cool thing um, that already totally exists and works really well. You can transfer like your voice into like a flute, and make like flute remixes of like singers if you want.
Yeah, that's sweet. That
it's
sorry.
it's kind of monophonic, right? It's kind of like a
Right,
monophonic thing still. So
right.
there's limitations, but it's pretty cool use of that so far that already is really successful, and there's a lot of plugins using it already.
Mm. Yeah, I'm really sort of like interested in ways of like kind of enhancing the accessibility of a lot of this stuff.
Yep.
Like I mean, even I'd say like kind of for most producers, still like I mean, and probably forever, I guess. Like even kind of opening up a Google Colab or whatever Jupyter notebook and then kind of training it. It's like it's not it's not that they're not able to do this, but it's like far enough outside of their sort of like their like kind of home field or whatever that feels like kind of not accessible enough in my opinion. There's
Yeah.
also I feel like you know that like sorry, I'm kind of like losing my train of thought a little bit, but yeah, I don't know. Where do you see yourself and your own work in that kind of like the do you feel like the things that do you feel like your work engages with that you're like trying to open up accessibility to artists to like play with this stuff? I mean, in a very real way with like your stuff with Ben and Rob and CJ, like that's basically the thing that you're doing is like letting artists play with these different models. But yeah, I'm just kind of interested to hear you talk more about that.
Mhm. It's totally my area of interest. I think that from the beginning with Dadabots, we thought of ourselves as kind of like producers or engineers in a studio would traditionally have been for a bunch of like, instrumentalists, where they're focusing on the art and the aesthetic, and they're there to capture the feeling and the emotion to get the best performance and all of that that no one at some big tech company is going to be thinking about that will make their music truly music and something to express to somebody
Hmm.
else, even if it's encoded into a model in some latent space. That source data is so important on how you put it together, and there's such an art to your sound corpus that you feed in when you train one of these models. I think of it like I'm like a model reliability engineer sometimes, where I'm trying to make sure that it's going to do what the artist thinks is their aesthetic, that they can sign off on the output of that model being within their sound world.
Right.
Um, and sure, it's kind of like a frame, it's like a loose framework or guidelines. I could probably write them all down and like be like, here's, if you have this type of data, do this, use these
Right, right.
augmentations, or like record more, get more variation. Um, all kinds of tips and tricks I could probably write down. Um, but like you said, like it's easy to just work with people these like right now. Maybe in the future, artists will have platforms that can do this on their own really, really easily, like a plugin that just works. I mean, we're working towards that with our tool, the combobulator, that
Yeah,
takes your
yeah.
sounds and allows you to blend with other artists' models, and using like the rave encodings to generate the sound for style transfer. But we're not quite there yet, with like mass acceptable, like we haven't, like, music hasn't had its chat GPT moment. In other words, like there
Yeah.
isn't like just like the one stop, like everyone goes to this website and totally understands how to use it type thing.
Hmm.
Right now I'm trying to be that bridge, and I love working with artists directly. So I like just figuring out what they have, what they'd like to achieve, and then like whatever shortcuts I know, we try to get it there. And a lot of times it's trial and error. I'll train 10 models or something, and it's just from experience.
Yeah,
Sometimes
yeah, yeah.
you fail a bunch of times doing this. So it's nice to kind of reuse that experience and get each artist to that level. So yeah, hit me up if you're one of those artists that wants to do that.
Yeah. Um, yeah, that's interesting. That made me kind of remember the thought I had from earlier of like I feel like those huge models. I mean, you see this a little bit with ChatGPT where it's like um, you know, they're able to generate like samples that fit the kind of main chunk of the distribution, like the main
Hmm.
part of the bell curve, but they sort of it's my intuition is that they sort of fail on these edge cases and sort of rightfully so, right? Like that's kind of the whole idea of this training is to like get it to generate stuff that's like within this
Yeah.
distribution. But I feel like especially in our kind of world of music and yeah, the like aesthetics that we like are generally outside of the main chunk of that distribution that like um that enough so that I feel like that like any sort of big company solution is going to sort of not be great at generating the kind of stuff that we like. So, which gives me a little bit of hope. It's like, okay, we got a little bit of lead time. We can kind of hack at this problem hopefully for a while and still do something interesting here and not get totally paved over. Um, yeah, what's your sort of like intuition on that? Like I know um I mean, obviously there's like a limit to how far in the future we can sort of predict, but like in my head, I kind of go back and forth between feeling like there that we'll arrive at this point where I'll be able to like use a model to make the kind of music that I want to make, like, you know, zero shot, like sort of like first
Yeah.
first output is going to be exactly what I wanted, enough so that I don't feel the need to like edit it or anything, and then that I can make infinite variations of that.
Hmm.
You know what I mean? Like, I don't know, what's your kind of take on what's the doomsday or utopian endpoint here? Maybe we should
Hmm.
do what's your doomsday, what's your utopian?
Okay. Got it. Yeah. So if we take ChatGPT, a lot of people are already noticing the first time you ask it something, it doesn't quite nail it.
Mm,
And you might have to be like, no, 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 look at this article and give me
mm,
something in that style, or like, look at this data and give me a response based on learning a bit more. And it's kind of like learning more as it goes, interacting with you and developing a persona that you want it to take. Um, with music, we make the metaphor that it's like the model is your spaceship, and we have all of these points in music that already exist that are genres or artists, and they're all like put into like a two-dimensional like set of constellations like stars, and
mhm,
the model is your spaceship to find out what is the space between these stars and what's there. What's between um, big band and hip hop? Like, where is right in between those two spaces? Is that something that no one has ever created as a human?
mm,
If you look under certain dimensions of the similarity between them, and can the model even get out of the distributions enough, or do they reach this like fog outside of the distribution where it's just like, oh, I can't actually see anymore, and
mm,
I can't even imagine, and it just becomes like so unpredictable. Um, we've seen that with previous models where even generating time, it gets to a point where it's predicted so many autoregressive samples that it's so unpredictable that anything could happen, and it just turns into like explosions of noise after
yeah,
that.
yeah,
And does that happen between conditioning and different styles too? I think that's like the utopian example is when we can truly use this as a spaceship to explore the cracks between the genres, because
mm,
people might criticize AI, synthetic media, machine learning, and say, oh, it just is derivative of the
yeah,
past examples that it's seen, so it can't create anything. It's maybe not pure creativity, but it could be still your vessel to go
mm,
explore and hear things that haven't really been hybridized before. Then there's the cultural thing, like what should be hybridized. Like
right, right,
so,
right.
some stuff just like doesn't make sense together, right? Like
Yeah,
there
yeah,
you can
yeah,
think of so many genres that would just suck if you just like combined them,
yeah.
and like what elements of those genres are actually what really resonate with us, and how could those be combined. And so I mean, I think the dystopian is where we get into these really predictable normal patterns, and you see it with pop. I guess like pop already does this. Sometimes people say
Yeah.
like, oh, that's generic, like it's derivative of like all these other pop songs,
Mm,
but that's also what makes it pop. Like it has to
right.
be familiar.
Yeah, yeah,
Otherwise it's weird and it's experimental. And I think the dystopian is where just there's like a team of marketing people that like have no idea like what is a good aesthetic, and like all semblance of art is removed, and maybe
yeah.
they're exploring these spaces, but they're not really pushing into new spaces because the other spaces are simpler to just keep exploring and optimize
Mm,
the local optimum amongst those. And
yeah,
we get more and more generic crap that we don't like, but
yeah.
that like, I don't know, the computer is convinced is like succeeding by the objective that the marketing team gave it.
Yeah, yeah, yeah. Yeah, I think like that's it's funny, that's actually one aspect where I'm sort of hopeful. Like if if no musician, I mean, I know some people really like doing this, and like, I'm not trying to throw shade at them or whatever, but if no musician ever had to make like an advertising jingle or like a rug or whatever, or even like if no musician ever had to make most pop in the future, to me that sounds a little bit like utopian. That
You like
that
it?
like
Nice.
there's like a part of me that's like yeah, those people could spend their time better probably. Again, sorry, no shade. I take it back if anybody's mad.
That's the
Like
artist's perspective, yeah.
yeah, that's it's I know that's like a personal vendetta perspective, I guess.
Yeah, yeah.
But yeah, don't take me too seriously on that. But yeah, so there's that kind of aspect where I feel like, that's in some senses to me that feels like the utopian dream is, or the initial utopian dream was that AI takes over all the jobs that we don't want to do, and then we're free to do the jobs that we do want to do. Fortunately, it feels like it seems like people are more interested in training models on the stuff that we do want to do. But whatever. Anyways, that's another discussion for another time. The other thing that what you were saying made me think of is like, you know, you're kind of describing this sort of like interpolation between um two kind of like known states, I guess, like these two
Yeah,
genres and in crude terms like country and I don't know, salsa or something. And then you
yeah.
find some point in the middle or something. I feel like to me there's like this also really utopian potential of instead of interpolating, extrapolating outwards of like, you know, this is our known space that all music that we've made so far kind of falls into, and then how do we kind of poke at the edges? There's a part of me that like was attracted to variational autoencoders and less autoencoders, but variational autoencoders in that
Yeah.
like there's it tries to find you a latent space that's kind of like in this normal distribution. It's like this sort of centered map, and then there's this potential to go outside of the space where you're getting these valid outputs. But all my experiments with this have been like that it just starts to be garbage really quickly. And I mean,
Right.
I guess this is sorry, this I'm going on this tangent here, but like there's also this feeling too of like from having banged my head against the wall trying to make experimental music and trying to make experimental music that people don't think is just like not music for so long. There's like I have this sort of feeling of like that you can't push too far past the edges, otherwise it becomes unrecognizable as like the relationship to where the boundary becomes
Mm,
like you're so far past it that it doesn't register as that, and there's no kind of connection to there's no like relationship to what people have already heard, and that makes it completely inaccessible. Um,
right. Yeah. It
but
becomes harsh noise, essentially.
yeah, or like
It's
even
too far from your cultural understanding that your neurons have fired patterns in a similar way before.
yeah, yeah, or like I feel like harsh noise we can get much harsher, like
Hmm.
yeah, I don't know, but yeah, the other thing that you mentioned and feel free to like jump in and interrupt me. I'm just like kind of following this train of thought that you sparked me on. But the other thing that you mentioned that I thought was really interesting was like the kind of question of is it creative or is it making new things or are all the things derivative? Like yeah, I kind of have heard a lot of these sort of like hot takes on both sides of like, yes, of course it's creative, or like, no, of course it's just like some derivative of the training data or whatever. But
Hmm.
my feeling has kind of always been that that's like the way that our brains work, where you have, you know, in a lifetime, you experience so many different sounds. And those sounds sort of shape these filters that you have on the random garbage that comes out of your subconscious or whatever.
Yeah.
And so when some, you know, the way I sort of think about it is like you have this random noise that just gets filtered through the filters of your taste. And then on the output, you get these like potential things, and then you have kind of a discriminator at the end, which is like, that's a cool idea, or nah, that's just a random brain fart, you know?
Hmm.
Um, yeah, I don't know. What do you think about that? What do you think about human creativity?
Yeah, I think that what we're hearing with stuff like diffusion, it can be so realistic and
Mm,
imitate a sound better than my voice can imitate a speaker, right? Like we're able to completely clone a person's voice with a filter. And this type of processing or generating or modeling, whatever it is, it's like a part of our brain that's really good at these really like specific like analyses of like the physics around us, of our
mm,
senses, and then there's the part of us that's like we call like the free will,
right.
or the part that's like a little bit more we say is like our autonomous, like our intuition. And these could be separate in computers too, and you can have a really unintelligent autonomous program like a virus,
Hmm.
and it's stupid. All it does is like it just clones itself and spreads. But it can have this like autonomous quality to go out and just make stuff like it makes itself. And
Yeah, yeah.
and then we have these neural nets that we're seeing that are really good at just like generating fake images. But do they have any like free will behind them? Any like autonomous decision making? Are they trying to express something to us? Do they have like a feeling in their heart about something that happened to them recently that they're like, I must put this into song form?
Right.
Like, not so much. We could add those, and maybe like reinforcement learning on top of what we're doing now would add more of like an objective or a reward that it's leading towards to share music and get a reward from that expression. That would be a step towards more pure creativity. But right now, like a neural net's just trained on like Rave is trained on Woog, and it just spits out Woog because it was optimized to do that. It's
Mm,
not like, oh, I would like to express this crazy dream I had, and I'm going to include everything I've ever
right.
experienced in my life when I and maybe I'll paint a painting, or maybe I'll write a poem, or maybe I'll make music. They're all
I
like
feel
one
like,
domain, right?
right,
Like a lot of the things that we're calling AI are pretty shallowly
right.
processed AI. It's not like truly out there in the world learning new types of art forms autonomously.
There's a part of me that is like sort of skeptical of, yeah, I mean, I don't know, maybe this is just like the edgy 15-year-old in me, but like, or 13, I don't know how old you're supposed to be when you stop being edgy, but there's there's a part of me that's like skeptical that that is really like really so different than just like kind of training a, I mean, even on like this idea of like, if you take that thought that I kind of had about like the noise pushed through some filters, and then you get this like at the end there's sort of this discriminator or whatever that says if it's good or not.
Mm-hmm.
I feel like there's in my thought, at least, if it sort of feels like that doesn't seem that different than what people do, that like, you know you have this, if you have an artist who makes music, right? So they have all this experience in making music and listening to sound and blah blah blah. And then they decide to make music based on like this heartbreak that they had or whatever. That doesn't feel that different than this sort of idea of like your network has an input, and then based on the layers of neurons or whatever, then it gives you an output. Like, So in this case, the training data would, for like a musician or whatever, the training data would be like their life experience, their experience of seeing other musicians do that transformation,
Mhm.
the kinds of music that they heard, which also I'm skeptical of like how much free will we have in terms of like what tastes we end up with. I'm getting real edgy over here. But yeah, there's I don't know, like yeah, there's a part of me that sort of questions like how is the difference just a difference of like the amount of complexity in the system, or is it really a difference in is it really a difference in type? Like that I mean, we talked about like that you're saying like our brains are not calculating partial derivatives and updating our weights and biases that are stored in our whatever. But
Right.
um, like the sort of basic idea of like you feed a bunch of garbage in, the internal components sort of align themselves so that or not garbage, sorry, you feed a lot of data in, internal components align themselves in order to generate more of that data based on whatever input signal. And then, you know what I mean? Like, that doesn't feel does that feel different to you? Like, is there like a major oversight here in my little edgy thinking, or what are your thoughts on this?
I think the philosophy makes sense that it's pretty similar to how human musicians are inspired by things. Our technology isn't quite as intelligent as that yet. It's
Mm,
like pretty much in one domain of like, here, imitate this audio that I already gave you.
right.
But in the larger pre-trained models, like we're talking about the large scale, many like thousands of artists trained, it gets closer to that. And then if you have some agent that learns how to manipulate that generative model in interesting ways, then yeah, we're pretty close. Especially if it's getting feedback from fans or the internet, or if it's what if we had other parts of the model that were like critics, like
Right,
we,
right,
we talk
right,
about generating music, but like what if we generated music criticism and we had like AI models making music for AI models that critique
yeah,
them and to judge them? I guess we're kind of in the same situation that we're in
right.
as humans, which yeah, philosophically this is kind of like futurist. Leads me to think that you could say that an AI that has listened to a bunch of copyrighted music is plagiarizing and stealing copyright just as much as we are as uh,
Right,
artists
right,
that
right.
have listened to all of the music that's on record labels that we love.
But I mean, that's kind of what I'm saying is like our our data set that we're trained on, right? Like our sensory input over however many years we've been alive. That's a much larger data set than anything we've ever tried, right? So to me, it's sort of like ignoring the sort of scale of it, right? Like if I think about like just because the scale is necessarily different, right? The distribution of data that I've seen is fucking enormous compared to like any model, right? But thinking about the mechanism of like I mean maybe the point that I'm making is fucking like doesn't isn't even really a point, but I don't know. There's like t yeah, to me it feels like there's this that's sort of the same system uh and I guess that was kind of the point of making these neural nets is like to try to emulate the same system. The one thing that you
Hmm.
said at the end there, I really like that idea of like, you said, oh, maybe that means that these are all derivative or whatever. Like if it's trained on just copyrighted music and then it makes music, does that mean that all the music that it makes should fall under the copyright of the label? My intuition is exactly the opposite, that like if it's doing the same sort of process that we're doing, this kind of like mix and mash blending sort of thing, which I like it. That's the extent of what I think human creativity is, which is maybe the edgiest thing that I've said. But to me, that sort of feels like then surely the output of the model should not be should not be copyrighted because if it's doing this thing that we're like, if it's generating new stuff in the same way that we're generating stuff, then to me that feels like it should obviously not be copyrighted unless there's some similarity to already, like, unless there's like a
Right.
super high similarity to something that's already generated, which is the same kind of rules that we abide by, right?
Same standard for people, right? Like,
Yeah,
oh, you
exactly.
stole my song that came out in the 1980s. Like,
Yeah,
clearly you already heard this.
yeah, yeah. All right. I guess. Fuck. I want to keep talking, but we should probably call it there. Um. All right. That was uh nice thought by Frothmouth about the Amen break. Very
Oh, totally.
super uh good example. That's what I'm trying to say.
Exactly.
All right. Well, thank you very much, Zach, for coming and talking to me. It's always a real treat to talk with you, and I hope I will get a chance to talk with you more in the future. Thank you, everybody, for joining us for this long and meandering discussion of AI and whatever else it was that we talked about. Um, and yeah, I just wanted to say. Shout out to my patrons on Patreon. And if you'd like to be a patron, sign up at patreon.com/woolg. And there will be more stuff like this. And maybe some perks. I don't know if there's really that many perks, but surely there's some sort of perks there. Zach, did you want to shout anything out or lead people in any particular direction?
Yeah, check out Dadabots.com. We have a lot of stuff come up on YouTube. And if you're an artist and you want to make some stuff or become a model, let me know.
Awesome. Okay, thanks everybody, and thank you.
Yeah.
Bye.
Thanks, Greg.
Oh, hold on. I'm gonna do some outro music here. Uh, oh wait, let's play this one because Wireframe Wolves is here.